Welcome to Praveen Patil College of Diploma Engineering and Technology. Myself Raj Gheware, working as a lecturer in Mechanical Department. We are looking on the subject Theory of Machine. So, in this subject, we have started with chapter number 4, Belt, Chain and Gear Drive. So, in this chapter, we have discussed about the gear drive, types of drives, types of belts, material used in a belt, and we have also seen about various flat belt devices. They were open belt drive, cross belt drive, compound belt drive, and in this part of the video we will be determining of angle of contact. So in this we are able to see these are the two pulleys, this one and this one. Now in this, when the two pulleys of a different diameter are connected by mean of an open belt, as we are able to see from the figure, the angle of contact or a leap angle, that is theta. See here, this is the part of theta angle. This is over here, it is located angle theta. Are the smaller pulley must be taken into consideration. So here let's consider R1 be the radius for the larger pulley, R2 be the radius for the smaller pulley, which we are able to see from the diagram naming also. And we can say that x be the distance between the centers of these two pulleys. So what we are going to take is, we will be looking for the sine alpha for this one, that is over here sine alpha, this value. Now in this sine alpha we will be going to take, that is OM, O to M distance, this one O to M. Let me highlight with this part. So this distance O to M distance divided by O dash to O2 dash, that is a formula of sine theta, opposite upon hypotenuse. So that is written over here. Now so this OM is also be written as this OM. Let me just clear out. This OM can be also written as total OE, this side total OE minus ME, and downside same as it is. So as we know that OE is nothing but R1 and ME as R2, and O to M distance, that is this distance, is known as X. So we have substituted that values. So when we substitute that values, we will be taking the angle of leap of contact, that is theta, equals to 180 degree minus 2 times of the alpha by 180 radiant. So this is all about the angle of the contact which has been determined for the pulleys. So in this we will be looking for the cross belt drive, how the angle has been determined. So here this is the required angle of contact for a leap, that is theta degree, is been found out for cross belt drive. Same procedure which we have to follow, which procedure we have followed in the previous one, that is for this open belt drive, and that we will be going for the cross belt drive. So in this is the part which they have considered, that is this one. So sine alpha equals to, this is the angle alpha located. So sine alpha they have taken. Now here also this angle is the alpha, this will be the opposite, and this will be the hypotenuse. So that only they have substituted, same process they have followed out, and on substitution we are getting for cross belt drive as angle of contact as 180 plus 2 alpha multiplied with pi by 180. So now let's see about the length of an open belt drive, how it has been determined. Now it's very simple. The length of the open belt drive, that is this part which we have to consider, the length we have to find out. Now in this, in order to determine the length, so here for the open belt drive, this is for the open belt drive. Now as we have seen, we will be considering the radius part, that is R1 and R2 will be the radius for the larger as well as for the smaller pulley, and the distance from the center of this two pulley, that is x, is considered. From the center of this two pulley, the distance is considered as x, and we will be saying that let L be the total length for this belt, total length of the belt. Now what we have to consider is will be considering that let belt of the larger pulley, that is at the E point which we are able to see from the figure, and G of the smaller pulley. So here the smaller pulley at F and H are shown, the point of contact on this pulley, the belt which is on the point of contact. So we will be going for the angle first of all. So the angle, that is angle MO2 and O1 equals to alpha. So this angle MO2 and O1, this is the angle which they have considered as alpha radiant. Now the length will be pi multiplied with radius of the larger plus the radius of the smaller, with additions of 2 times of the distance. So 2 times of this distance is considered, that is this distance, 2 times of this distance plus r1 minus r2 the whole square. Now instead of r1 minus r2 we can also write down as diameter. So when we write diameter, as we know, so r is nothing but d by 2. So this 2 value which goes to denominator side of both, it will be becomes 4x. So hence we will be getting the final term as like this. Now apart from this, for the cross belt drive it's one and the same. Only thing is there is a variation in the part of a cross belt drive. So here for the cross belt drive we are getting the term as only the sign part has been changed. Here there is a positive plus sign, here there is a plus sign, whereas for the open wheel drive there is a minus sign, as we are able to see. Same process which we will be following, and we will be getting the determination of this cross belt drive. So this is how the length of a open wheel drive and a cross belt drive has been determined. Now let's discuss about the creeping of belt. So exactly what is a creeping of belt is, let's consider this two pulleys and there is a belt which has been located over here. Now as we know that in this part of the diagram, let me draw the central axis of this. So here when the belt moves along this path, so when the belt moves from tight side of the pulley to the slack side of the pulley, so what will happen is at the point of contact, so belt will tends to extend. So if the belt tends to extend, so there is a change in the length of the belt occur, so it will affect on the transmission purpose. So this is known as the creeping term of a belt, and it's in velocity term it has been given by n2 by n1, that is for the first pulley to the second pulley, equals to diameter of the first pulley and divided by the diameter of the second pulley multiplied with the Young's modulus towards the stress in the belt produced. So this is how the creeping of the belt has been determined. So in this we will be looking for the slipping of a belt. So how the slipping of a belt occurs? So first of all, the creeping of belt occurs when, see, whenever the belt moves along the pulley, so there is a friction which is there between the pulley and the belt. So that friction will hold the belt from the shaft firmly. So if there is a insufficient amount of frictional grip between them, so it will result into slipping of the belt. There will be arising of slipping of the belt produced. So in this terms, the velocity of the belt passing over the drive per second is determined by the velocity, that is pi diameter of the driven member and its rotation speed divided by 60. Now here the S1 and S2 are nothing but the slips between the driver and the belt, and the belt with the follower. So this is all about the slipping of belt. So in the next part of the video we will be discussing on the velocity ratio of the belt. So that's all for today. We will stop here. Thank you.